Hello students, welcome to Neet Gateway. Today we are going to discuss the class 7 chapter motion part 4th video. Okay, so if you are not see the previously the 3 videos means provided in the description. Okay, so kindly see that and make use of it. Okay, so today we are going to see the topic was graphical representation of a motion. Graphical representation of the motion. Yes. See, we have saw the motion and we have came across some problems related to the motion and we have seen that some parameters related to the motion. Here we are going to study the motion through the graphs. Okay. So before studying the graph, you should know the basic understanding about the slope of the graph. So what do you mean by the slope? Slopes will tells you that. So for example, this is the graph. This is the x-axis and this is the y-axis. So if you if you got a graph like this in a straight line means it tells you that how it is gentle or it is very steeper. So okay, எவ்வளோ சாஞ்சு இருக்கு, it tells you the slope means in Tamil we say it as a சாய்வு. Okay, see, so with respect to the horizontal surface, how the diagram appears, how the graph appears. So in the same graph, the graph also like appears like this. Who is more steeper here? Yaar romba saanjirukra? This one, because this is very less and this is very more steep. So compared to whether comparing these two, this is gentle and this is very steeper. Okay, so this is the slope. So this is the conceptual understanding of the slope. How we can represent in the mathematical form, that must be very important. So slope is represented by the letter called m. Okay, it is represented by two coordinates. Okay, one x coordinate and other y coordinates. So y2 minus y1 divided by x2 minus x1. So simply we can say m is equal to y by x. Okay, so y2 minus y1 means it gives you some y value. x2 minus x1 means gives you some x value, right? So y by x, y axis divided by x axis. Slope is equal to what? Y axis divided by x axis. I'll show you the diagram. You can get it very confidently that, so you can easily understand. As I told you, slope is nothing but rise and rain. Rise is what? The change in y and the change in x, which is m is equal to y2 minus, this is the change in y and change in x. Okay, so it tells you about how much it is steeper or gentle. Okay, and what are the types of slope? There is a positive slope. So in the graph, if you got a line like this means it is the positive. Okay, so negative slope means in the graph, if you got the graph like this means this is the negative slope. You should remember this. Okay, so in the graph, if you got the graph like this manner means, okay, like this manner means it is a positive slope. Whether it is in a opposite manner means it is in a negative slope. When it becomes a zero slope? When you didn't get any graphs or else you are getting graph parallel to the x-axis. All x, y, x, y, x, y. See this graph is parallel to whom? X-axis, right? When the graph is parallel to the x-axis, then the slope is what? Zero. Very important. When it is undefined, it can say it as an infinity. When it is means, so x, y, x. When you got the graph parallel to the y-axis, means then it is undefined. Let us see one more time. When it is positive, it is a straight line, increasing manner. When it is negative, it is in a decreasing manner. Okay. When it is zero, parallel to the x-axis. When it is undefined, which is infinity, parallel to the y-axis. Okay. Okay. Till now we have saw the basic introduction about the slopes. So what is a slope and what are the types of slope we have saw? Yes or no? So now we are going to apply this slope and graph concept in motion. So we are going to describe the motion through the same parameters. What are the parameters we are going to take? First parameter is distance and time graph. Okay. So distance and time graph means one axis should be contain one quantity and another axis should be contain another quantity. So whether distance comes in x or time comes in x. or we can place any one of them either in any axis? No. See here, the very important point is, which quantity is the independent quantity? Among the two quantities, there are two quantities, distance and time. Which one is the independent one? It does not depend on anyone. So, the independent quantity should be placed in the x-axis. Independent quantity. The independent quantity should be placed in the x-axis. Very important. And the dependent quantity, the other quantity, the dependent quantity should be placed in the y-axis. So, among these two quantities, distance and time, which one is independent and which one is dependent? Okay. Make your answers in your comment section box. See, time is independent. So, I can't able to stop the time, right? Nobody can able to stop the time. Time keeps on moving. So, it does not depend on anything. Okay. So, among these two, distance and time, time is independent. So, you should always keep times in x-axis and distance in y-axis. Clear? In distance and time graph, if you take the slope, the speed of the graph project what? Okay. Okay. In distance and time graph. So, time should be in y-axis and distance should be in x-axis. Y-axis. Okay. So, there's a straight line like this. What is slope? You know the slope formula is what? Y by x. What is y here? Distance. By x is time. What is distance by time? Distance by time is speed. Okay. So, from this you should remember that in distance time graph, if you take slope means it will give you the speed. Okay. In distance time graph, if you take slope means it gives you the speed. So, remember this mind. Okay. Steeper slope, faster speed. Flat slope, stationary, 0. Negative slope, returning or moving toward the starting point. See here, there is a blue line graph and the red line graph. Which one is more steeper? Which means, idu romba saanjirukku. So, how we can find this? Draw an horizontal line, common to the both lines. Which one is having this is smaller angle, this will be the bigger angle. Which is having the bigger angle? The red line is having the bigger angle. So, it is more steeper. Which means, it has high slope. Compared to the red, blue one is gentle. So, gentle, which is low slope. Okay. In distance and time graph, if you take slope means it will gives you what? Speed, right? So, which one having the more speed? High slope will have the more speed. High speed. Due to high slope, it is having high speed. Due to low slope, it is having low speed. Can you able to understand? See, in distance and time, first you have to see, draw an horizontal line. Compare the both graphs. Which one is having greater angles? Whether the red line or the blue line. Blue line is having smaller angle and red line is having bigger angle. Form the angle with the horizontal line. Okay. Wherever the angle is greater means you can say it is more steeper, which means it is having high slope. In distance and time graph, if you take slope means it will give you the speed. High slope means high speed. Gentle slope means low slope. Low slope means low speed. Got it? Okay. So, now we are going to study the different case studies in the distance time graph. So, what are the case studies? In distance, all are distance time graph. Okay. All are distance and time. Okay. See here, in distance and time, this blue line, there's a line. This line represents what? Okay. In all the points, so consider this point. In this point, the angle is theta. Consider this point. The angle is theta. Consider this point. The angle is theta. Corresponding angles. You have studied in the geometry, right? All throughout the graph, theta. Theta means the angle is same. Angle is the same means what I have told you. Angle same means slope is same. Slope is same. So, slope is same means what you can get. In distance and time graph, what is slope? Speed. So, speed is automatically same. So, this kind of graph tells you a body is moving in a same speed, which means a constant speed. Can you able to get that? When a body is moving in the same speed means you should draw the graph like this. A straight line. So, it is a positive slope, right? Positive slope. Okay. Next, one by one, okay. Constant speed, right? We have saw the constant speed. So, at every point, At every point, draw a horizontal line. Horizontal line parallel to that. The horizontal line should be drawn parallel to the x-axis. Draw a horizontal line. So angle making is corresponding angles always same. All the angles are same. Okay, you should remember that. So I will tell you the technique here. Distance time graph. dt means what? Distance time graph. Distance time graph. Next BT graph. Next AT graph. So keep this in mind. We are going to discuss only distance and velocity time graph. Okay. In distance time graph, if you take slope means what you will get? Velocity. In velocity time graph, if you take slope means you will get what? Acceleration. Okay. Keep this in mind. In acceleration time graph, if you take area means it will give you velocity. In VT graph, if you take area means it will give you the distance. I will write this now. I will explain this very later. You can easily understand that. Okay. So now you understand for a constant speed why the graph is a straight line. Okay. For stationary, when a object is in a stationary means how does the graph looks? Stationary means whether a speed should be what When a body is in a stationary position means at rest position the speed should be 0. What is in distance time graph? What is speed? Slope is the speed. So slope should also 0. So for which diagram slope will be 0? I have already told you when you draw the graph parallel to the x-axis means the slope is 0. Which means at the 5th meter for every time, so for a time is equal to 1 second I am here. For time is equal to 2 seconds I am here. 3rd second I am here. 4th second I am here. 5th second I am here. So for 1 to 5th second whether I have moved, whether my position is changed? No. I am staying in the same position. So my speed is 0. So the graph will be straight line parallel to the x-axis. Got it? Accelerating. So listen this. In distance time graph, acceleration means what? Rate of change of velocity. The speed should be increases. The speed should be increases. The velocity should be increases. Okay. So the velocity should be increases. How it can increase? See, velocity, change in velocity. Change in velocity is acceleration. We can say positive acceleration. Okay. So take it as a positive acceleration. So change in velocity means change in speed. We can also say this as a change in speed. So positive acceleration means increase in speed. Increase in speed. We can say it as an increase in speed. If the speed want to increase means what should be in the graph should be increase. Which quantity in the graph should increase? So in the graph the slope should increase. Slope should increase. Because in distance time graph slope tells you the speed. In distance time graph slope tells you the speed. See here in this point it's make angle theta, very smaller angle. In this point draw the horizontal line, very bigger angle. In this point very bigger. Okay. Whether the angle is increasing? Yes or no? At the every point from 0 to keeps on moving, right? So angle is increasing. Angle increasing means what? Slope increasing. Angle increasing what? Slope increasing. What is the slope in distance time graph? What is the slope? The slope is speed. So speed is increasing. So speed increase means the body is in acceleration. The speed is not in a constant speed means then it is not acceleration. When the speed is increased means it is in acceleration. So for acceleration you should draw like this only graph. Got it? Yes. See here, analyze this graph very well. Okay. From here to here, consider this point. This is A point and B point, and this is C and this is D. Okay. From A to B, what is happening to the slope? So listen the slope very well. Okay. The slope is straight line means slope is constant. Slope constant. Slope constant means what graph it is? distance time graph. So in distance graph, what is slope? Speed. So speed constant, which means a body traveled from 0 to 2 seconds. From where to where? This is the time. From 0 to 2 seconds, the body from 0 to 2 seconds, body traveled with constant speed. Body travels with constant speed. See here, from B to C, what is the slope? It is the slope is 0 here, right? When the line is parallel to the x-axis means the slope is 0. So from B to C, slope is what? 0. Slope is 0. So slope is 0 means speed 0. When will speed will be 0? The body is in rest position. So from where to where? From 2 to 4. From 2 to 4, 2 to 4. 2 to 4 seconds, body is in rest position. Speed is equal to 0 means it is in rest, right? Okay, next. Okay, on the very types of graph and the types of slope I have told you, positive slope, negative slope, zero slope, undefined slope. How should the negative slope looks like? It looks like opposite to the positive, like this. So this is the negative slope. So which one is negative here? Speed is negative. Speed is negative means what does that means? So it is returning to the starting position. It is returning to the starting position. So from C to D, slope is negative. Slope is negative. Slope is negative means speed is decreases. Negative means decreasing meaning, decreased. So return to start position. Return to start. Okay. Okay. Next is velocity time graph. Okay. Here velocity time graph. Same way distance time graph, we are going to discuss the velocity time graph, VT graph. Okay. So in VT graph, if you take slope means it gives you the acceleration. Okay. So which one going to be in the x axis? Always the time. Time is the independent. Velocity in the y axis. Okay. So slope. So slope is what is slope formula? M is equal to y by x. What is y here? Y axis is velocity. Velocity by time. What is velocity by time? Acceleration. Got it? Velocity by time is what? Acceleration. Okay. So we are going to see various cases here for velocity time graph. Okay. Let us discuss that. So you should keep remember in velocity time graph, if you take slope means it will gives you the acceleration. If you take area, this is the area under the graph. This is the area. This area is equal to what? Distance or displacement. Distance. Got it? So let we discuss this area later. Now focus on acceleration. In VT graph, if you take slope means it gives you the acceleration. This only have teach you slope is equal to what? Velocity by time, which gives you the acceleration. Okay, velocity equal V2 minus V1, time is equal to T2 minus T1. Yes. So see the different cases for constant velocity at rest position, accelerating when the speed is increasing up. Acceleration means speed is velocity is increasing. Decelerating means velocity is decreasing. Okay. So we are going to see these different cases. Okay. First, constant velocity. What do you mean by constant velocity? Your body is moving with the same velocity. Uniform motion. Constant velocity means uniform velocity or uniform motion. Okay. So for example, I am traveling in 5 meter per second. 5 meter per second means throughout my journey, my velocity is 5 meter per second only. Okay. See here. For all time. So constant velocity means acceleration is what? For acceleration means change in velocity. Whether velocity changes here? No. Then acceleration, whether it produces acceleration? No. So acceleration is 0. So in velocity time graph, what is acceleration? Slope is the acceleration. So acceleration is 0 means slope is also 0. So for constant velocity, slope should be 0. So which graph gives you the slope 0? The axis parallel to the x-axis. The line parallel to the x-axis gives you the slope 0. Can you able to understand this? Yes. At rest position. At rest position. Okay. Listen this. In velocity time graph, In rest position means whether the body moves, no. So it does not have any velocity. See here, at velocity 0, the graph is straight line. It does not have, throughout the time, all the time the velocity should be 0 only. So you can draw like this also, or simply you can draw like this. If you didn't draw any graph means, in VT graph, there is no graph inside the graph line means, it represents that the body is in rest. The body is in rest. You can leave as it is. This is also the correct answer. Or you should draw on the 0. Put 0 here and draw like the straight line. Through all the time, the velocity is at 1 second velocity is 0. At 2 second velocity also 0. At 5th second velocity also 0. 6th second velocity is 0. At every time, the velocity should be 0 only. Or we can else draw a blank graph. Next, accelerating. So accelerating means increase in velocity. Increase in velocity. Okay. Increase in velocity. Okay. Yes. Velocity should increases. Velocity should increases. In velocity time graph, what gives you the slope? Acceleration. So for constant acceleration, the slope should be, so it is for uniform acceleration. Name it as uniform acceleration, not non-uniform. Uniform acceleration means constant acceleration. Constant acceleration. For constant acceleration, slope should be also in constant. For constant slope, the graph should be in positive. It should be the positive slope because increase in velocity. Positive slope. Got it? Yes. Next. Decelerating. Decelerating means what? Decrease in velocity. Decrease in velocity. Decrease means it will always tells you that negative slope. Negative slope means simply you can draw a straight line like this. Yes, a straight line like this. Decrease in. So decrease in slope. Decrease in slope. Acceleration. Constant, here also constant acceleration. Not decrease in slope, sorry. Not decrease in slope. Here also decelerating means constant slope. In negative side, in negative. Constant slope in negative. Because of decrease in velocity. So constant slope in positive means should be drawn like that. So if it is a constant slope for positive means you should drawn like that. If it is a constant slope for a negative means you should drawn like this. So the slope is not decreasing here. Slope is constant only. Why it is negative? For decreasing in velocity. So here slope gives you what? Acceleration. Here also acceleration. Whether it is not accelerated, it is decelerated. So for deceleration only we are saying decrease in velocity. Okay. Okay. Here we are going to see the area under VT graph. So I have told you, right, in distance time graph if you take slope means it gives you the velocity. In VT graph if you take means slope means it gives you the acceleration. In VT graph if you take area means it gives you the distance or displacement. Okay. In VT graph, VT velocity time graph, this line means what? Constant velocity. What is the area under the graph? This is the area. This is the whole area, right? So in the question they will give you they give you the graph like this. What is the displacement? What is the displacement? Displacement is equal to what? Area under VT graph. Area under VT graph. Okay. What is the area under this graph? Okay. So what the shape look like? It looks like a square, right? Okay. Not square, rectangle. So what is the length of the square? 4 into breadth of the rectangle is 5. Area of the rectangle is what? Length into breadth only, right? So it is 0 to 4. 4 and 0 to 5. Length into breadth. So 20. Okay. 20 meter. Displacement unit is what? Meter. 20 meter. Can you able to understand? This is the way you can find the area. So if the diagram looks like this means In VT graph, if you get the diagram like this, means this gives you the acceleration, right? Okay. So what is the area of this? This is the area of the triangle, right? This is the area of the triangle. What is the area of the triangle formula? Area of the triangle is equal to half into base into height. Half. What is the base? 0 to 4, which means 4. What is the height? 0 to 8. Okay. So 1 times 2 times 8 2s are 16. So in area of the triangle, what is the area under velocity? Displacement. So displacement is equal to 16 meter. Yes, meter. Got it? If it is square means use a square formula. If it is a triangle means use a triangle area formula. See here. Whether it is a square or triangle. Okay, we cannot able to segregate, able to structurize this, right? So the best way here it is to do segregate, decompose the graph. How we can decompose? See. So this is the graph. Okay, let me use the different color. So I am drawing black. This is the graph. Okay, the graph, the black color gives you the graph. Okay, what is the area under the graph? This is the area. The green full is area. Yes or no? This full green is area under this graph. How we can segregate this graph into known quantities? See here. This is one triangle, right? One triangle, and here one rectangle, and here one rectangle. Simple. If you all add the areas of this, you can get the total area, right? So what is the area of this triangle? Area of the triangle. Okay. What is area? Half into base into height. What is base? Base is from 0 to here, 2. Into height is 2 to 6. Up 6 minus 2 is 4 then. So 2 to cancel, 4 meter. Okay. Because velocity time graph displacement, right? So 4 meter. So triangle is over. Next is rectangle. What is the area of this rectangle? So area 1. Area 1 is over. What is area 2? This is considered this is the area 2. And this is area 3. This is also a rectangle. Okay. From where to where? 2 to 4. This is the area of a rectangle. Length into breadth, right? So length is 2. 4 minus 2 is 2. And breadth is 2 minus 6, 4. 4 2s are 8 meter. Finished. And this is the area 2. What is again area 3? Area 3 is also a area of the rectangle. See here. What is the length? 0 to 4, right? So 4. 4 minus 0, 4. Into breadth is how much? Breadth is 0 to 2. 4 2s are again 8 meter. This is the area 3. What is the total area? A1 plus A2 plus A3, which gives you 4 plus 8 plus 8, which is equal to 20 meter. This is the area. Area under VT graphs gives you the displacement. So displacement is how much totally? Displacement is equal to 20 meter. Okay. If they give you the complex graph also, what you should want to do? Don't be fear. Just segregate the given graph into the known shapes. Okay. Yes. So we can discuss more problems related to the graph in the next section, the next video part, and the part number video 5. So till now wait for it. Thank you.